All right. Hi, welcome everyone. Thanks for your interest in this subject. I know it's a mouthful of a title, Advancing Models for Sustainability Science, Health Effects of Climate Change. That's a lot, 15 minutes, but I know the ultimate aim of this workshop is to help support interdisciplinary grants in math for complex climate challenges. So I'm trying to be here and reflect what I think some of those opportunities are from the main communities I work in, which are modeling methods to help support understanding whether interventions are consistent with sustainable development, which is equitably improving well-being, and the community interested in the public health implications of climate change. So Sarah Birch showed this animation in her talk, which reflects the fact that the climate system affects everything. Climate change affects all of these variables in terms of sea level rise and temperatures and atmospheric concentrations. That affects a variety of exposures and pathways that affect human health, and that ultimately affects a variety of human health outcomes. And I like to, in particular, focus on air pollution, and I'll explain why. So if climate change has a big impact on health, that's good news, because it means that addressing climate change can offer local, tangible, near-term benefits to our health. And that helps counteract some of that super wicked problem that Sarah was describing, where our incentives are to not act. But if we can make this more personal and more near-term, then those incentives can change. So, green diets are often healthier diets. Active transportation is lower carbon and can be healthier for you. And reducing sources of carbon pollution also reduce sources of air pollution and improve air quality. And I'm so pleased to see that in their latest assessment report, Health Canada is adopting this optimistic position, pointing out that the potential health co-benefits of climate action are so significant that climate change is the greatest global health opportunity of this century. And the actions that we take across multiple sectors to address climate change can achieve very large multiple health co-benefits. And so we've looked at this, for example, by end of century, if we don't act, there was a question this morning about the cost of inaction. And if we don't act, climate change can lead to additional tens of thousands of premature deaths, thousands of heart attacks, millions of lost work days by end of century, every year just in the US. Okay, and this is all just associated with air pollution. But climate policy can be highly protective of those additional risks. This is work we did in the US, but we have similar results on their way for Canada. It's a similar story. Okay, so why are these air quality health effects such a big deal? Why focus on air pollution? So it's a very optimistic talk, but also a bit morbid, so bear with me. These are the major causes of premature death worldwide. So these are in number of deaths annually in millions, okay, so up to 10 million annually. And these are the risk factors that contribute to death. Okay, so top 10 here, not too surprising: high blood pressure, smoking, high blood sugar, high body mass index, high blood cholesterol. Number 6 is outdoor air pollution. Number 9 is indoor air pollution. Okay, and they're associated with a variety of outcomes. There's number 6, a variety of outcomes, including multiple causes of death, heart disease, lung disease, respiratory infections, cancer, maternal and neonatal outcomes. So overall, that's why it's the leading environmental risk factor for premature death. And here in Canada, we think we enjoy relatively clean air. We do, but this is still a over $100 billion a year problem for the economy in Canada. So climate change is going to affect air quality. Climate policy can potentially improve air quality. And there's a variety of ways that this happens. So first of all, climate change is related to greenhouse gas emissions, GHGs, which affects climate change. climate change, these are changes in weather variables, things like temperature and precipitation and wind patterns. All of those contribute to air quality levels, the transport and formation of pollutants. Also, many sources of greenhouse gas emissions are also sources of emissions of air pollutants. So if you're burning a fossil fuel like coal, for example, you're going to have greenhouse gas emissions. You're also going to have particulate matter and all sorts of other harmful compounds come out of it. So if you, for example, eliminate coal-fired power, then you're improving air quality, reducing emissions, improving air quality, and all of those have benefits for human health and the economy. So we know there are going to be these big important changes with the climate and on health associated with air quality. So the goal in our lab is to understand what these changes are going to be so that we can inform our policy responses to emissions and to air pollutant emissions and to the climate in ways that hopefully, does improve well-being and health while meeting our climate goals. We specifically try to address this question in ways that help us understand and deal with some of the complexity in this problem. So, for example, the climate system is going to have major effects throughout on air quality, and also if we deeply decarbonize, that's also going to have major implications. So we want to understand that. We know that our responses as well have to be, pervasive, and so there are going to be effects across sectors and across jurisdictions. So what happens if we work together, and what happens if we don't? And then equity, sustainability is all about, equitable well-being. And so, of course, we have to better represent that in our analyses and promote equity. And of course, so many sources of uncertainty. And so these are our focus areas, but in general, the question is, given that we have to respond to this climate crisis, what are the key interactions and feedbacks and uncertainties that we need to prepare for if we want to equitably improve health? So how do we try to tackle this problem? Well, it's a variety of integrated modeling methods and data-driven approaches. But generally, we try to understand, if we implement a policy, what's going to be the effect on the economy, on air quality, human health, and economic benefits. So we try to, a big focus is trying to understand sort of national level responses to this challenge. So we borrow a lot of tools from technical policy analysis of environmental quality, so that they're familiar with what we're using. But again, with this view of helping to understand the systems level problems and complexity. So one thing we can answer with these approaches is, if we're going to do something, where do we start? And our work has found that everybody should pitch in, every sector should help. And just very briefly, we found that these are just the health benefits associated with improving air quality, and they can be larger than the entire cost of a climate policy in a given year. That's not a fair comparison, but they can be if we have a cost-effective policy, and the most cost-effective policy engages all sectors of the economy. But if folks aren't cooperating, if you can't get cooperation, for example, across political boundaries, it's still better to go ahead and act. You can still, again, get larger local benefits due to improved air quality if you implement a climate policy by yourself, regardless of what your neighbors are doing. It's not just the total benefits that matter. Obviously, one component of equity is distributional equity. So understanding who gains and who pays. And we've, ours and other research has found that air quality improvements and climate policy can be equity improving. And this is a modeling study, against household income. And we also have data-driven studies that have looked at decreasing health disparities by improving air quality in China. Okay, an area of interest for us that I want to highlight specifically for this group, I'll spend a little more time on, is this coupling between mitigation and adaptation. Okay, Sarah highlighted, we have a national adaptation strategy, that's great. And my first questions for them, okay, well, how do you consider mitigation with that? Because we absolutely cannot separate these responses. And we know from studies that include adaptation responses in climate mitigation studies that it's going to affect that temperature level that we get. So we know we have to account for both of that. And here we're looking specifically at, well, what if folks adapt? You know, if air quality is getting worse, people might take steps to change their behavior to protect themselves. And in particular, you know, I mentioned that Health Canada report, public health authorities can't enact a carbon tax. They can't affect system-wide climate policy, but they're very concerned about what they can do to protect human health. And so we looked at, you know, given their current capacity to encourage adaptation to air quality, which are through air quality advisories, what can they do to protect folks under different levels of climate change action? So to represent this, we are using a whole toolbox of different methods, where first, to understand that global environmental change, that global climate policy piece, we have modeled the global economy under different levels of climate change policy. We've used that to drive Earth system model and atmospheric models that can give us a suite of future scenarios of air quality. Then we, so these global economic models involve what are called economically rational actors. These are geniuses with perfect information who always do the best things for themselves, just like all of us, right? And so we represented those folks to see what's the best we could do in terms of protecting ourselves through short-term adaptation. So that's moving indoors to protect yourself from poor air quality outdoors. Okay, that's the main guidance that Health Canada and the health authorities can provide. And then we talked to Kristen Madure, who you heard from this morning, who can represent social influence and social learning and some of this bounded rationality where folks have to learn and maybe don't have all the right information at the right time. And so we're trying to understand the difference between these outcomes so that we can inform adaptation policy. So we find, you know, that again, cost of inaction, climate change increases air quality advisories. Okay, so in these black bars, this is our reference case. Okay, so the number of air quality advisories will go up over time by end of century if we don't enact any policy. But if we do, if we enact a policy in gray, this is consistent with the hitting 2 degrees. We do at least limit that rise in air quality advisories. If we don't enact climate policy, if we say you're on your own, folks, it's up to you to decide whether to adapt. And you wanted to, this is just the regionally differences in air quality advisories up to 3 weeks in some areas. And if we said you are on your own to protect your own health, and we forced you to adapt to the same level of health protection that would be given by climate change policy, folks would have to stay inside about 73 days a year. Everybody just did that for a little bit. I don't know if we're too eager to spend a lot of time trapped indoors again. We've also looked at this, this role of social influence, and we do find that, the folks with perfect information and the folks who are socially influenced are going to adapt in similar places, but that social influence means that they're going to adapt a little less and with lower net benefits. So given this, I want to be very clear that the benefits of climate change mitigation for health are significant. And you can only get a fraction of those, even with the people with perfect information, through adaptation, short-term adaptation. Okay, and you're also shifting that burden of doing that solely to individuals. So there's some equity implications there. However, our goal was to say, okay, public health authorities, what can you do if we don't have a world where we're mitigating carbon sufficiently? And we were able to find policies to help promote some of that individual agitation under different levels of climate change. So even given uncertainty in where we might end up in terms of our ambition, we can encourage individual adaptation. A big part of that is compensating folks for protecting their own health. Okay, so I know I have to wrap up, but I just wanted to point, when I think about where are the frontier challenges in these spaces, I point to these three communities: public health, modeling dynamic systems. There's a great upcoming special feature, and multi-sector dynamics is an excellent community in this area. And they have a special feature that's going to come open for abstracts in June. So just something to think about. And I won't go through all, but that's where I think some of our common challenges are, regardless of where, you know.
I'm gonna give you let's let people look at this slide because it's really important.
Okay.
So you've just been gifted an extra 30 seconds.
Okay, I've been gifted an
go
extra
on,
30 seconds.
Go through this slide.
Thank you. Thank you.
That's
Thank
exactly
you,
what we asked you to do.
Excellent. Thank you. So from those, knowledge assessments and vision exercising from those other communities, working with folks across sectors and different modeling techniques and different things they're interested in about, these are some of the cross-cutting challenges that we see. How do we know that we're modeling our system right? How do we know we have all the right stuff in there? How do we know when we're done? How do we understand what's causing what? Okay, and this isn't just models, this is models interacting with data, this is process-based models, data-driven models, etc. Related to that are these, are we capturing important linkages and feedbacks? How do we cross scales of impact and action from local to global? These are global environmental changes. And human systems, I think Mador pointed out that, hey, it's the human, the human system parameters that have the bigger impact. We consistently find that it's, the kind of uncertainties or levers in the human system are very important to better characterize. And all of this is to help understand, how the heck do we know what we're doing is actually going to be consistent with equitably improving well-being in the long term? And so to that, we really have to think about deep uncertainty representing equity in our modeling process. So that's both in the process, and recognizing equity issues and understanding the distribution of outcomes. And I think part of the solution is that there are transdisciplinary communities. So that starts with interdisciplinary communities like this, who then try to inform action and operations.
Okay, thank you so much.